Hey, today's video is on Cal.ai. Cal.ai is an AI that helps you schedule meetings and look at your calendar. It was #1 on Product Hunt a few weeks ago. Here you can see it had over 1,000 upvotes, and it's part of the broader offering from Cal.com. Cal.com is an open source Calendly alternative. Disclaimer, I'm a small investor in Cal.com, and I'm also getting some free credits for creating this video, but I was planning on doing this video anyway, as it's a great open source project to learn from. I'll quickly show you the product and then we'll dive into the GitHub code behind it to understand how it was built. How does Cal.ai work? Let's say Alison has sent you an email and is asking, are you free at 10 a.m. tomorrow? Then Pierre responds with, yes, let's do it, and he CCs his Cal.ai into it. And then Cal.ai goes and books it automatically in his calendar. It's as simple as that. The email gets sent to the AI then does its magic in the background, it talks to the Cal.com APIs, and it books the slot in your calendar. And that's it. To make it work, you get a username on Cal.com. Everyone has a username anyway. It will look something like this, Pierre@Cal.ai. And now this is your email for your assistant. You can forward it emails, you can send it emails, and it will go and automate your calendar for you. Let's take a look at some of the other features. You can ask it, what meetings do I have today? And it will respond with your calendar. You can tell it to reschedule your meetings for the next 3 days. So then the AI just goes and does it. And the last thing it can do, if the user's using Cal as well, then it can find other people's availability as well. So for example, Sally has 3 slots on Monday. Will I book one of these? And the AI has suggested 3 times that you can book with them. So I've gone and cloned the project. Locally, I'm running it here in VS Code. And the first thing you'll notice is using Turbo Repo. So classic signs of Turbo Repo, you've got an apps folder, and then you've also got a packages folder. You can also see the turbo.json. This is what T3 app and a lot of others provide you out the box. I'm not going to cover everything that Cal.com does in this video because it's a huge repo. You'll see there are tons of different packages. Even within the apps, we've got about 6 different apps. Within the packages, we've got another 20 packages or so. It uses things like Prisma, TRPC, bunch of other stuff. What we're going to be looking at today is the AI app. Just want to give a quick shout out to myself. I'm the sponsor of this video. I'm building an open source app called getinbox0.com. It's basically an app to help you manage your email better, get to inbox zero faster, and lots of analytics around it. So hope you enjoy, take a look, link in the description below. So let's take a look at this. The AI app isn't too crazy. You'll see we have around 7 packages here. I'll quickly go through what the packages are. Prisma, this is just the Prisma package where we're getting all our types from. If I just quickly jump to this, you'll see this is a full database for Cal.com. It's around 1,000 lines of code, and every app or package that uses the database imports it. T3 OSS end of Next.js, this is a really great package. If we go to the MJS file, so this is how environment variables are defined for the project. It uses Zod to make sure everything has been defined. So here you can see server variables, you also have client variables, and so on. And so what's really great about this is often an app is going to completely break if it doesn't have a field set as an environment variable. So for example, imagine you're running the app and you've forgotten to set database URL. You set it locally, but then when you deploy to Vercel, you forgot to set it in Vercel. So this is like a super common bug. It can crash your app very, very easily. I've had this specific bug so many times, and whenever I don't use a checker for this, I always run into issues. So I'm in the habit of adding this to every project I build right now. T3 OSS, it provides you a lot out of the box, but you don't need to use all of it. You can just use this package standalone. Langchain, we're going to cover that a lot in the video. Mail parser, can help you parse emails. It's using Next.js, supports Cal.ai. I don't think that's even used at all. Maybe it needs to be removed from the project. And then Zod is the last one we're using for validation. So as you can see, not really many packages. If we take a look at how this Next.js app is built, we see we're using the app directory, and we've got 3 API routes: agent, onboard, and receive. And this really is the core of Cal.com AI. So yeah, this came first on Product Hunt. It got 1,000 upvotes. It got a lot of attention, but behind the scenes, how this was built was really quite simple, and we'll cover it in a few minutes today. So if we take a look at the README, we'll get a clear idea of how the project was put together. So the first thing that happens is you are sending an email to your Cal.com assistant. Now what happens next is we have Sendgrid that's listening for all the inbound emails. We've basically got an inbound pass webhook. So what this means is every time a certain email address gets an email, Sendgrid then sends us the details for that email via a webhook. And that webhook is received over here in receive route.ts, which we'll cover shortly. So basically, we get the email, then we pass the email. That's basically coming into the /receive endpoint. Now we're going to do all sorts of stuff with Langchain, but basically we'll create a prompt with it. We'll put a bunch of different tools. So tools in Langchain are basically functions in OpenAI, if you're familiar with function calling. And the tools available are the different APIs that Cal.com has for the user. So one is create a booking, get availability, and so on. And then a tool is selected. We'll call the Cal.com API. That's basically the tool automatically does that. The AI just has to choose which tool it wants to use. Then we'll go and make the API calls and so on. We'll get a response, and then we'll send it back to scheduling agent. This is a Langchain agent. And what this will do is it will keep doing it again and again and again. If it's got 5 different tasks to do, it will go and do all 5. It will call lots of different endpoints until it's accomplished everything it needs to do. And once that's all done, it's going to send an email back with something like, hey, I just scheduled your appointments for the next week, or I rescheduled your email, or I rescheduled your calendar, and so on. And so that's the overall flow. This chart might make it look more difficult than it is, but I hope that's clear. Basically, we have an inbound route, and then after that, we do some AI stuff. We choose different tools to use. The AI chooses different tools to use. And then the last step is we'll send an email back to the user, and we would have performed any actions we wanted along the way via the Cal.com API. So let's take a look at receive. This is the first endpoint we're using. So first, point out we have a max duration of 30 seconds for this endpoint. If you're not familiar with this, this is sort of Vercel will respect this. If this is deployed on Vercel, this serverless function can run for 30 seconds. Now we have a post route. Again, if you're new to App Router, this is what API routes look like these days. Everything's in the app folder, and you export a function with the name post or get or delete or whatever type of function you need. So you don't need to do checks. Is this a post method or a get method? Because it's done automatically by Next.js, and it's done because it knows the name of this function. Next step is to verify the passkey. This is to check that we're actually getting an email from Quaker. All we're doing is checking the passkey in our environment variable. We also have a passkey, and we're just saying if they're equal or not. So that's very simple. If it's not verified, okay, someone is calling this API without permission, let's throw an error. Next thing we do is we go and take objects from the form. So this is how Sendgrid is going to be sending us the data, and we're going to pass it and we're going to get the result. And in envelope, we're going to get a whole bunch of fields. Now, something I don't like about this, that I would do better if I was improving it, is I don't know what is going to be on the object, what errors I could run into. It's dangerous. You're basically losing the benefits of TypeScript. And it's not difficult to fix this up. There's a few ways to do this. You could type the object here. The other thing to do is the same way as we validated this is coming from Sendgrid up here. You could also validate here with Zod. And once you validated it, we'll know exactly what this envelope type is. Anyway, so that's a small improvement I would have liked to see. We get a bunch of information from the email. So we get who it's been sent to. We get the subject. Then we check the rate limit. This is done with Upstash. If you're not familiar with Upstash, we covered this a little bit in previous videos. I don't want to go over it now, but basically it's a rate limiter. It uses Redis behind the scenes. If you're sending too many emails to this service, it's going to throw an error back at you. So even if you're authorized and you're a user of it, it won't just let you spam it with 1,000 emails. If you have been rate limited, we're going to get an error over here. So thanks for using Cal.ai, but you've reached your daily limit. What we do next is we pass the email. So the email we get from Sendgrid is in a specific format. It's a big jumble. An example email payload looks something like this. It's something that needs to be passed into a proper format, and that's basically what Simple Parser is going to do for us. And that is from the mail parser library. So we've passed the email. We need to make sure it has text, and we need to make sure it has a subject. If not, again, we're going to throw an error. Now what we're going to do is we're going to find the user. Now how are we going to find the user? The email address that sent us this email, we're going to check for this user in the database. So this is using to check the Cal database for this user. Next step is to check for the signature. So DKIM is basically a way to verify that the email hasn't been spam. It's from the person. It's actually from you that this email is being sent. And ensure if we don't find the user signed up or the signature isn't set, we're going to throw an error. Next step, we're going to find credentials on the user. So the user has a credentials object. We need to find the app ID. Now the app ID is because Cal.com has an app store with lots of different apps you can use. And so for this to have worked, the user first has to install the app on that Cal.com account. If we take a look here, we'll see the different apps we have available to install. And here you'll see we have the Cal.ai app, and we can go click and install it. And here we can see more details about it as well. If the app has been installed, then we will basically have credentials for it. And if we don't have credentials, we're going to throw an error. Sorry, you're not using this app yet. You should add it and then you can use it. Assuming you are using credentials, we're going to use the API key from the credentials. And this API key is going to be used to interact with the Cal.com API. So the first thing we're going to do is we're going to use our API key, and we're going to fetch the different event types from the API. We're going to fetch the user's availability. We're going to extract users. And so this is just some prefetched data that happens automatically as soon as an email is sent to us, assuming we've gone through the validation correctly. If there's an error for any of the above, we're going to send an email response, sorry, there was an error. And now the main part of what happens, this is where the actual logic is happening. We will do a fetch request to the API agent. And that is over here, agent/route.ts. You can see we're sending it a post request, we're sending it all the different information, the information we've just fetched and so on. And this is an interesting one. We wait 1,000 milliseconds, so 1 second, and then we respond here. Now, why is this happening? Basically, what they wanted to make happen, this endpoint from receive would respond automatically to the Sendgrid API to be like, yeah, we've handled it. But the AI part of it can actually take a lot longer. So for example, imagine I sent my AI assistant 10 different tasks to do over email. That could really take a long time because GPT is somewhat slow. So we need to make sure this actually sends and then we respond okay. Now, the most natural way to do this is actually to do await, fetch, and so on. But if we did it like this could take like up to 5 minutes to respond. So we don't do it that way. And if you're wondering why don't we just not await and just let it do that and not wait the 1,000 seconds? Well, if you do this, then this might not actually ever be sent because basically this function is returning here, and this function fetch, it could take, I don't know, maybe 100 milliseconds or more to complete, and it won't actually even start the process if we've already shut down this process, which happens when we respond with okay at the end. So what I would say is a bit of a hack, and you might not want to use in production. You would want to use it in production here, but in other cases you might not want to use it because you're making your users wait an extra second. There are other ways to handle this. Another way to do it is push the work onto a queue that responds immediately. But for this use case, it's completely fine because the only user that's waiting is Sendgrid, and Sendgrid doesn't mind waiting a second for the response. Anyway, that's the receive function. We've covered all of it right now. In short, it gets the user and then it gets some basic information about the user. It passes off the task to the AI agent, which is another endpoint, which we'll look at in a second, and then it responds okay at the end. So let's jump into the agent. This is using Langchain to do what it needs to do. We start off with max duration, 300 seconds. That's up to 5 minutes. That's the maximum that the cell allows, unless you're using edge functions. This is quite a recent update. That's quite nice. I think they realized people need a lot more time for serverless functions, especially if you're doing AI stuff. So now the maximum limit is 5 minutes instead of like 30 seconds or something that it was before. Next step, okay, we have a post request. Again, we're using the same pass key, basically checking that it's actually us calling the API key or Sendgrid calling the API. We're gonna get the JSON from the request. Here are all the different fields we sent over. If we're missing a field, we're gonna return an error. Again here, I would way prefer to use Zod. And if any of the fields are missing, you can just use Zod to pass that. And then also each of these would be typed. Right now, everything is any because we're not using Zod. We're going to start the agent, and that's this function over here. And then once the agent has done its job, we're going to send the response to the user. And if there's an error, again, we'll send an error. So there's not a lot in this file, but the core logic is within the agent file. So let's take a look at agent. First, what we do is we grab all these different tools that I mentioned at the beginning. So get availability, get the user's bookings, create booking if available. So this actually changes data on Cal.com and in your calendar. Update booking, delete booking, and send booking email. The next step is to set up AI with Langchain. So we pass the OpenAI API key. We set temperature to 0 to make the response deterministic. So it's basically give us the same response each time, or as close to the same response as possible. There's no need for us to get creative here. It's not like we're writing content and we want something different every single time. And we give the model name, and we're using GPT-4 for that. You can see here the packages we're using. Langchain is where we're importing chat OpenAI from. Now, if this is all we were doing, we wouldn't need to use Langchain, but the next part is actually where Langchain becomes helpful. So here you see the prompt we're sending in. So Langchain, that's the prefix. We're using OpenAI functions. If we want to see each step on the way, that can be set over here. And if we want more logs, we can use webhook. And then we call OpenAI via Langchain, and then we get the output and we return it. The main thing that's happening here is the prompt that we're sending over. We'll read it a little bit. You are Cal.ai, a bleeding edge scheduling assistant that interfaces via email. It sends a bunch of information about the user. This is the user's ID, the username, this is the time zone, and so on. These are different event types that we fetched before. Here are the working hours when a user is available, and so on. These are the usernames that have been referenced in case we want to interact with them. And overall, you can see all we're doing is just passing a whole bunch of information. We've given a few rules. So you can see tools will always handle times in UTC. The times sent to users should be formatted per that user's time zone. In response to users, always summarize necessary context and open the door to follow up. For example, I have booked your chat with @username for 3 p.m. on Wednesday, December 20th, etc. Please let me know if you need to reschedule. So this is another good practice to do when you're writing prompts. You can give an example for example output. But if you notice, we've given some rules, we've called OpenAI, we've given it some functions to call, but there's not actually that much else. And so the magic here, and this is actually something I didn't know and I'm really happy I did this video so I could learn it, was that these different tools, the AI figures out how to use them. And it's not just that it can use them one by one, it can actually use all of them. And once it's used one, it can use the next one and the next one and the next one and so on. And 2 days ago, OpenAI actually released an update that you could call multiple functions. Like OpenAI can now call multiple functions when doing function calling. This wasn't possible a few weeks ago. But beyond that, what is really nice about this, even beyond just multiple function calling that's possible, it can do multiple steps. So Langchain agents, if you're not familiar with them, that's what we're using here. And an agent can just keep doing more and more and more on its own. So it could take like 10 different steps. And when I spoke about show intermediate steps, that's what's happening over here. So if we're in development mode, it's going to return the intermediate steps. And that basically means the first step is get the booking availability. The second step is send an email to John. The third step is save something in the calendar and so on. The fourth step is maybe you've also told it to delete a previous booking. So it can do 5 different actions all within one email, which is quite amazing. And there are a lot of reasons not to use Langchain, but functionality like this I think would be very difficult for you to code up yourself without wasting a lot of time if you're just using plain OpenAI. The last step is to understand how tools actually work. So let's say I want to do get availability. What's happening here? The get availability is in the tools folder in getavailability.ts. Here you can see we're using a dynamic structured tool. This is part of Langchain. But what's important is here there's a function that's being passed to it. You can see the name of it. You can see a schema. It's using a Zod schema. So here we are using validations. These are the arguments that we're expecting to be passed in to the function. Here you can see them up top, user IDs, date from and date to. And here you can see what actually happens when we do this. So here we want to get the availability for all these different users. So we do fetch availability. And if we take a look in here, you'll see we basically make a call to cal.com to the availability endpoint. We pass in the different URL params and we get a response from cal.com whether the user's busy, the time ranges, time zone, working hours, and so on. And so this data can then be passed to OpenAI and the AI can use it to make decisions. Let's just look at one more agent. So let's say create booking if they're available. So same thing, dynamic structured tool. We're going to have a function that we can call. Down here we're going to have a schema with the different parameters it can take in. And here we actually go and create the booking. And creating a booking, again, we're getting some parameters. We're calling the cal.com bookings endpoint with the different parameters we passed in. And here we get the response, send it back. And that's us creating a booking via the Cal.com API. That's it, basically. I mean, I'll show you one more thing, which is your onboarding. This is basically a welcome email. Really, not a lot happens here, but the user is fetched, and then we basically send a welcome email to welcome AI. That is basically sent when someone clicks install app. This app is in the App Store. So if I quickly take a look for where this appears in the codebase, you'll see it's over here in the App Store in Cal.ai. The App Store is another package, and this is where you can create your own add-ons for Cal.com. Really cool. And each of these is their own mini package. So for example, this has one endpoint, which is get add. We can basically add users to this. And to do that, all we have to do is call Cal.ai/API/onboard. And once this has been called, the user is basically getting that email. And then everything else doesn't happen through Cal.ai. You're interfacing it via email. So you send an email to Cal.ai and then it manages everything for you. And if you want to see, here are some more components of all of this text is exactly what we're seeing on this screen over here. Book a meeting, example questions, and so on. So what's displayed there is basically the code for it is over here. And this is part of the cal.com website, and this is part of the App Store package. That's the end of the video. I hope you enjoyed it. Please subscribe. It really means a lot to me. Feel free to ask questions below. Every week I do a new video on a different open source project. Typically I'll cover full stack projects. I like to cover AI projects as well. A lot of Next.js, Tailwind, Prisma, that sort of thing. Yeah, I hope you enjoyed it. I hope you learned some things from it, and see you next time.